Good.
Okay, welcome to Klein's Geometry. Today we're going to talk about lesson 11.4, inscribed angles. We want to be able to find out the measure of an inscribed angle and use their properties to solve problems, which means we're going to learn their properties. So, inscribed angle, little vocab for you, is an angle whose vertex is on a circle and the sides contain chords, and the sides are circle, chords of the circle. So it might look like this. If you've got a circle, here's two chords, that's an inscribed angle. The vertex is on the circle, there's two chords, and the intercepted arc are the endpoints that are on the sides. So here's our intercepted arc. So all the points in between this end and this end. And we say the quarter arc subtends an angle if its endpoints are on the side, so that's going to subtend that. You don't hear this a lot, but I thought I'd throw it out there just in case. Odd vocab. These are important. Inscribed angle in the green, point on vertex on the circle, and there's an arc. Intercepted arc is across from it. Okay. So, and you're going to see some pictures where there's quite a few of them in there. And you always just let your eye follow the chords to the arc. So, here's another picture of one. DEF, inscribed angle. DF, intercept arc. DEF subtends to arc DF, or the other way around because they're across from each other. Okay? And here's the big news on this. This is the thing that needs to be in your notes. The measure of this angle, you know, the measure of the central angle equaled the measure of the arc. Well, when you move that angle from the center to the other side of the, to the other side of the circle, this angle is half of this arc. So the measure of the inscribed angle is half the measure of its intercepted arc. So if this was 20, that would be 40. If I told you this was 60, that would be 30. Just, if you know this, double it to get the arc. If you know the arc, divide it by 2 to get the angle. Okay? You might see it, you could see it as a diameter, you could see it just kind of anywhere on there. I don't know why they call those three cases. Bottom line is, inscribed angle, arc across from it is twice as much. So, let's find angle measure PRU. Find the measure of angle PRU. And what I would do is I would look at P to R to U, and I'd say, okay, there's my intercepted arc. I need half of 118, and that's all you do to find it. Write down, you just need half of that, you get 59 degrees. So I know this angle is 59 degrees. Now when I want to find arc S to P, that's right here, and I look at this angle, I see it's 27 degrees, so to get the arc, I do times 2, and I've got 54 degrees for my arc. And they started with their formula and then multiplied both sides by 2. So you can do it that way, or you could just think as I move out onto the circle, times 2. As I move into the angle, divided by 2. Now this is where it'll get interesting. A little corollary to that is you can have something this interesting, lots of stuff going on. If inscribed angles of the circle intercept the same arc, they've got to be the same measure. So notice, here's my arc, A to B, and I could take ACB, that would be this arc. I could go AD to B, that would give me this arc. I could go A to E to B, that would give me this arc. They would all intercept the same arc. So if they do, all those angles are the same. So when you're in search of angle measures, that's all you're looking at. If they intercept the same arc, they must be the same length. Okay? So let's look at this. We're going to do three things. We're going to find the measure of angle ABD. we're going to find arc BC, and then we're going to say what other angle is congruent to ABD. Let's start with that. I see ABD intercepts this arc right here. So I think here's ABD. Let's make that another color. A to B to D. And it intercepts arc AD. So the first thing I'd say, okay, then the measure of angle ABD must equal half of the arc. So half of 86. So it's going to be 43 degrees. I also know, if I look, what other angle is intercepting this arc, and I can see ACD, C's on the circle, that also intercepts this 86 degree arc. So ACD is congruent angle ABD because they both intercept the same arc. So that answers that question. Now we want to find the measure of arc BC. So we're looking for this one. Well, let's get rid of all this other stuff so I can see. I'm going to have to find myself an angle, an inscribed angle. If I go from B, hey look, there's a point on the circle over here. So BAC intercepts arc BC. This is 60. Well, we've got to do times 2 to get out to the arc. So that arc must be 120. So the measure of arc BC equals 2 times 60. So I have 120 degrees. So remember, when you're going from the little bitty angle out to the arc, times 2. When you're going from the arc into the angle, divide by 2. So there's our 3 answers. And we'll just take a second to go through all this because now, following that, if your inscribed angle subtends to a semicircle, well, a semicircle is 180 degrees, so that means this angle must be 180 divided by 2, 90. So an inside angle subtends to a semicircle if and only if that inscribed angle is 90 degrees. So you might get something like this. Find A. And I'd say, well, I see that this WXY is a diameter. So if it is, this is a semicircle. And if that's the case, then this angle has to be half of 180 or 90 degrees. So if your endpoints of your angle are on a diameter, angle's 90. So to find A, you just set 5A plus 20 equal to 90. Take away 20, divide by 5, and you know what A is, okay? Just following your algebra down. So just be aware of that little corollary on there. And one more corollary for you, if you've got a quadrilateral inscribed in a circle. Well, the opposite sides, angles, are supplementary. Here's why. If I looked at angle A, that's this angle. Well, that subtends this arc, BCD. And then if I look at C, well, that subtends this arc, DAB. Can you see how we just used the entire circle? And the circle is 360 degrees. So half of 360 is 180. So this angle plus this angle have to equal 180 degrees. And you could do the same thing going the other way. So that means the opposite angles of a quadrilateral, if they're inscribed in a circle, will always be supplementary. Okay? So to find angle measures, you get something like this. Just find 2 angle measures that they gave you a expression for. So I would think, okay, this and this are opposites. So this plus this have to equal 180 degrees. So to find the value of B, set those two angles equal to 180. Simplify. Remember to add your like terms. 9 and 45, 9B and 45. Take away your 45, divide by 9, and get your B. Once you've got that, you just plug it into those three expressions. Put in 9 here, here, and here to get these three angles. The fourth one, well, you know there's 360 degrees in a quadrilateral. So plug it in to get angle G and get 70. Plug it in to get J and get 110. Plug it in to get to K to get 81. And then you know, well, you know all three are 360. You also know that K and H are 180. They're supplementary. So you can take 81 away from 180 to get H, which is 99. So, or you could add all three of those up and take it away from 360, whichever. But it's handy to know those opposites are supplementary. So set the two opposites, their sum equal to 180, find B. Plug in B, find three angles. You know H is the supplement of B, so you can take it away from 180. So, a lot of good stuff. All the bottom line is any inscribed angle is half of the intercepted arc. And from there you just know, well, if two angles intercept the same arc, they must be congruent. You know that if it intercepts a semicircle of 180, it must be a 90-degree angle. And if a quadrilateral is inscribed in a circle, those opposite angles have to be 180, supplementary. Their sum has to be, because they're between their two angle measures, they're going to hit the whole circle. Okay? So that's 11-4, and see you in class.